So if we are looking at this, okay, number one is your own answer. All right, it asks you to give an example of any sport, and list out two categorical, two numerical variables. So can someone write down a sport and then put two categorical variables? Want to do that? Share your answers. Basketball, all right. And what were your categorical variables? Okay, so outcome of the game, win or lose. James and A, you said, what was the other one you said? Do you make or miss the shot? So there's two categorical variables for basketball. Outcome of the game, win or lose. Outcome of a shot, make or miss. All right. Who has a sport that they use for numerical variables? Huh? Football? Okay. So can you give me a numerical variable for football? Yards per game by a running back, yards per game by a quarterback. Because you're measuring a distance. That distance is measured in numbers. Right? What about another numerical thing that can be listed in football? Numerical variable. Passing yards. Okay, passing yards is the same thing as yards, but yes, passing yards if you want. Catches, how many catches does this person have? Alright? You can measure the number of catches per game that people have. Good. So really, an easy way to do that, guys, is numerical. Put stuff that involves like time or distance in your sport. Alright? And so numerical, think of time and distance. Alright? Categorical, think of ways that you classify stuff. Alright? So, for instance, we're thinking about this. So right here, I want you guys to tell me, is this a categorical variable or a numerical variable? For a football player, the average number of yards per carry in one game. Michael, what would it be? Would it be categorical? Why not? It's measuring distance. Distance is numbers. Alright? Well, yeah, average, but it's the average yards. If you think about it, you average 170 yards a game. Alright? So that's going to be a number. So average number of yards per carry is numerical. For a basketball player, the shooting percentage during one game. Why would it be categorical? When you shoot, what's the outcome? It's either a make or a miss, or a miss or a make. Alright, so that shooting percentage is broken up into make or miss. Alright, what about for a baseball player, his batting average during the playoffs? It could be numerical because you're thinking, okay, it's going to be like he bats 300 or something like that. But what is that batting average made up of? It's made up of hits and outs. How many times does he bat is made up out of hits and outs. So you're classifying each at bat as a hit or an out. Okay? Numerical, I don't know what I'm saying. For a hockey player, the time on ice per game. That'd be numerical or categorical? Numerical. Why? Time is numbers. Alright? We're not classifying time in a category, we're classifying time as a measurement of numbers. Like minutes and seconds. Alright, so That's that. Now, by a show of hands, the graphing part, is that a struggle or not a struggle? Finding the averages, and how many of us had some issues with graphing? Or think we have issues with graphing? You just need to use what? You need a calculator? Alright. So what I want to do, just so we're all clear, because here's what happened. I don't think a lot of you guys did your homework today. And if you did, you're like afraid to say that you need help if you actually need help. Right? Because as I'm walking around, I'm not seeing too many graphs out and about. You're supposed to have your homework out checking it. Not seeing too many people with graphs. Alright? So what I'm going to do is I want to go over, we'll look at number 3 and we'll look at number 5. Okay? Number 3 and number 5. That way you have in a full-on example of what we did to solve, to do those problems. All right, so, that being said, I'm going to need you guys' help. All right, so, number 3 says, in the 2007 season, baseball player Alex Rodriguez hit 54 home runs and 583 at-bats. In the 2007 playoffs, he hit 1 home run and 15 at-bats. Create a bar graph to compare these performances. Briefly describe what you see. Okay, again, if you don't have this done, I don't want you to be working on it. You should be going through this problem, write the problem down with me. All right? Not just watch me do this because I feel like talking. It's, you need to know how to do this, and if you don't know how to do this, you need to walk through it with us. Number 3. Okay, so first of all, it says create a bar graph, not a staggered bar graph. So this means that the bars are going to be side by side. Okay? So I think I remember saying something yesterday. What's the first thing that you should do when you're getting ready to create this graph? Huh? Gather all the data. Data's been gathered, okay? I think if we go back here, when comparing distributions, it is very important that the percentage or proportion of observation in each category be displayed rather than the number of observations. So what do we need to do to all the data that we have? We need to convert it into a percentage. Thank you, Dan. So, what we do to convert that into a percentage is we look at this, we see what we want to figure out. It says 54 home runs, 583 at-bats. The number 54 and the number 583 are not going on my graph. I need to turn that into a percentage. All right? I need to turn it into a percentage of home runs. All right? How do I figure out the percentage of times that he hits a home run? Huh? Not over 100. But do something with those 2 numbers. You got to add. Not going to add. Divide what? I'm going to divide the home runs by the total at-bats. All right, so here we go. We have home runs divided by total bats. So that is, if you look at that, what is it? 54. 580, you said 3. Alright, so I'm going to divide that. Okay, 54 divided by 583, if you type that into your calculator, you get 0.092. That is 9.2%. Okay, so this is equal to 9.2%. What that means is that Alex Rodriguez, he hits home runs 9.2% of the time. So, if we know that he hits a home run 9.2% of the time, okay, what percent of the time does he not hit a home run? How do you figure that out? No, he hits a home run 9.2% of the time. So we're going to take 9.2% of the time, so percent of no home run would be equal to 100 minus 9.2, which is going to be equal to 90.8. 90.8%. Okay? Now, am I done finding percents? I'm done for the regular season. This is the regular season right here. Alright, so I should probably label this. This is my regular season that's written in blue. But I'm also given data about his postseason. Alright, so postseason, let's do that in red just so we can see the difference. Okay? To figure out the percent of times he hit a home run in the postseason, I would do what? I would do the same thing, except that I'm going to use the numbers from the postseason instead of the regular season. So it's home runs divided by total bats. Home runs was, what was it? 1 divided by total bats was 15, which is equal to 6.6%. Okay? Now, someone tell me, how am I going to find out the percent of times he doesn't hit a home run? Subtract what from 100? So I'm going to subtract, so percent of no home run is equal to 100 minus 6.6, which is equal to 93.4. I'm writing 33.4 for something. 93.4%. Alright? Now I have all of my data that I need. I have all my data for the regular season in percent. I have all my data for the postseason in percent. Okay? So, what we have to do now is graph this. And we have to think, okay, a segmented bar graph means that I would group the postseason together and the regular season together. In this bar graph, I want to compare my home runs to home runs and no home runs to no home runs. So I'm going to group the number of home runs together and I'm going to group the no home runs together. So, to make my graph, alright, I have to label my axes. And 20, 30, 40, 50, 60, 70, 80, 90. I'm still going to go to 100 because I have numbers that are up in the 90s. Alright? So, I take my percent of home runs for the regular season. That's 9.2%. That's underneath 10%. So I'm going to go here and I'm going to put that there. Almost 10, not quite. Alright? I would label that by putting in the percent if this marker did not force me to write really fast. Then, the percent of home runs in the postseason. Do that in red. You got 6.6. So it's a little bit less than 9.1, but a little bit more than halfway up to that 10. Okay? So this is home runs. Alright? Now we have to graph our percent of no home runs. 90.8% of the time, he doesn't hit a home run. So 90.8 is like right above this 90 right there. Right there, maybe. So 90.8% of the time, no home run. Then percent of no home run in the playoffs, is 93.4. That's a little bit more than this one. All right, so maybe like that. Okay, so now I can see that percentage. And now I have my graph, which I just need to add one more label to. No home runs. So then the graph asks me, or the problem asks me to briefly describe what you see. Someone describe what you see. Just describe it. What do you see? Make an observation. Huh? There's a lot of home runs. You can say he hits a lot of he doesn't hit a home run as often as Kurt. He hits less home runs than he does anything else. What else can we say? Does he hit more home runs in the playoffs or the regular season? Regular season. Okay, so you could write he hits more home runs in the regular season. Does that make sense? So then that's how you make a bar graph. You always start out by getting all your data written in percents. Okay? So we're going to look at one more problem. All right, and I said number 5. Number 5 says, in the 2009 regular season, basketball player Candace Parker. Anyone know anything about Candace Parker? Yeah? You know something about her? What do you know? Anyone know anything else about her? Anyone know that she went to Columbus City Schools? Candace Parker? I forget where she went, but anyone know that her mom was the PE teacher at my middle school? Alright? She plays in the WNBA, basketball player. So it says, in the 2009 regular season, basketball player Candace Parker of the Los Angeles Sparks made 131 shots of her 270 shot attempts. In the 2009 playoffs, she made 38 of her 71 shots. Create a segmented bar graph or bar chart to compare these performances. Briefly describe what you see. So the first thing I know is this. Okay? It says segmented bar graph. Immediately that means I know that I'm going to be putting the regular season and postseason the regular season together, postseason together. Why? Because my total has to total up to 100%. Alright, so what's the first thing that we need to do? I'm going to start calling people that are asleep. Alright, the visa. What's the first thing that we should do? Mike, what's the first thing that we should do? Find the percent. Thank you. Alright, so we're going to find the percent of makes. This is number 5. So percent of makes. Alright, how do I do that? I'm going to divide something what? So I'm going to divide the number of shots she made by the number of shots she took. Yes. Alright, so what is it? 131 divided by 270. Alright. 48.5. So how can I figure out what percent of shots she missed? Not divide, subtract this from 100. So percent missed is equal to 100 minus 48.5, 51.5%. Okay? So we're done with the regular season. I should probably label that. If I'm doing my work, I want to know if it's my regular season. Now we need to do the postseason. All right, we'll do this in red. Postseason. Who said something? What did you say, Tiana? we need to do the percents for the postseason. Tiana, do you know how to do percents? We need to do, what did we do up here? We did percent of makes divided by total shots. So we need to do the same thing for the postseason. We are going to divide, so we need to do total shots made, or we need to do shots made divided by total shots. So she made 38 shots in the postseason. So percent made, she made 31%, or 31 shots. She took 71 total shots. So you do 31 divided by 71, and you get 61.7. Okay? And how do we find out her percent that she missed? Tiana, do you know that? Subtract what? Which number? This one? So we're going to do 100 minus percent made. So 100% minus 61.7, that's going to be 38.3%. All right? Now we got the wrong number. We got 31 to 38. Yeah, we switched a little bit. What are you saying? Oh, I'm looking at the wrong number. You got 30, you got 31 to 38. Oh, yep, I see. Thank you. That should be 38. Alright, so 38 divided by 71 will be what? 53%. 53.5, okay. And then we're going to do 100 minus 53.5. And we're going to get 40.7. No. Don't do that real quick in the calculator. 46.5. 46.5. Thank you. So, now we have to graph it. So, graphing a segmented bar graph much easier. Okay? All you do, your rectangle has to go up to 100 because that's total percent. It's 100%. That's total. So you go 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. And you're going to create a rectangle like that. And I guess we're doing, we'll just make this the regular season. So what you do is you see, okay, what did she make? She made 48.5% of her shots, right? So I go 10, 20, 30, 40, 48 right there. So I go make, miss. Okay? So, we do the same thing for postseason. Postseason, go up to 100. And then, you see, okay, she made 53.5% of her shots. So I go 10, 20, 30, 40, 50, 3, over, makes. Oh, look at that one tomorrow, guys. Actual form. This is. Yes. You go right in that corner. The water on the bottom. Grab one. Alright, so we're done at that point. The only thing that I would add to this, regular season, postseason. Okay? Questions about that? Now imagine that this sounds much more simpler now. Good idea, because that's what you guys are about to do. Man, you should be a teacher. Alright, so let me finish this sentence real quick. Just make sure we got everyone. Jean, where's your sister today? Is she here today? Alright. So, we're going to look at this problem right here. Okay, so my question to you guys is this. And again, you don't have to write this, you don't have to write all this down, because these notes will be online. So what you can do is write down the answers to the question, and then you can always go back and look at the question online. Alright? So, the question is this. Does uniform color make a difference? So for instance, just to give you an idea, if I wear my red team, if I wear my red jersey, does that make me better? Does that make me better at what I do? Or if I wear my blue jersey, does that make it so that I'm going to win more? So it says, in some contact sports, and again, you do not need to write down the whole problem. The questions that we answer, I was in saying. Alright? It says in some contact sports the answer may be yes. Researchers Russell A. Hill and Robert A. Barton collected data on 4 sports during the 2004 Summer Olympics. In each sport, competitors were randomly assigned to wear red or blue during their matches. The table below shows the number of wins for competitors wearing each color in each of the 4 sports. So it shows in boxing. Out of 272 total times, the red person wearing red won 150, blue won 122. Taekwondo was 45 for red, 35 for blue. Greco-Roman wrestling was 25 and 26. Freestyle wrestling was 28 and 26. Okay? So our goal is to figure out, does it make a difference? So, up here now. So, for the first problem, the first question I want to ask you guys, alright? For each event, do the results in the table summarize a categorical variable or a numerical variable? Take 5 seconds to think about it real quick. Okay, so you see that it has red, you have your red uniforms, your blue uniforms, and then you have each of your sports. So what would it be? Categorical with red and blue. So you got it. So categorical, all right, or categorical lines, as Michael said. So it is categorical because we're breaking up the athletes into red, like sort of like red team, blue team. All right. So red team, blue team. Now, the next question says, if the color each competitor was wearing has no effect, on the outcome of the match, what percentage of the matches would you expect the red contestant to win?
I just want to remind all of our teachers of 9th and 10th grade students, the 12:15 bell is the bell that releases them to lunch. The next few bells will start the middle school class for the rest of the block. Again, 9th and 10th graders should not be released for lunch until 12:15. Thank you.
All right, so if I tell you, okay, the color each competitor wears does not have, so it has no effect on the outcome of the match, what percentage of the matches would you expect the red contestant to win? What? Why? It's kind of like the thing about the coin. You have your. Well, it really does not matter what you wear. So you have, you're either, so when you're doing this, if you're boxing, you're either going to win or lose. You have a 50-50 chance, 50% chance. That's half. All right. So what percentage of the matches would you expect the red contestant to win? 50%. All right, because each person has the ability to win 50%. So you expect red to win 50% of the time. Because each athlete has a 50-50 chance. Or you can call that their ability is a 50-50. Yes. Okay, so obviously, yes, there's a little bit more that goes into it. All right? Taking the skills into consideration. But regardless, okay, even with skill, if Ohio State is playing, say, Linden in football, I'm giving you an extreme situation. You guys, technically, you have a chance to win or you have a chance to lose. No. Technically, you have a chance to win or lose. It's 50-50 no matter what. You're either going to win. You're either going to win or you're going to lose. Now, there might be that random chance that we've been talking about where you guys have a 50% chance of winning, but then there's like a negative 500% chance of random chance flying in there and knocking down your guys' chances.
Who's last? Not Rooster, over.
Who's that?
The last team,
D3, Oberlin's a D3 school now that they're the last in-state opponent to beat Ohio.
How long ago?
Can you go back this one?
1923.
Well,
Right.
all right. So here's what I want you guys to do now. You guys are going to do this. I want you guys to display this data with a bar chart. I'm gonna go back up. I want you guys to create a bar chart. Okay? I want you guys to create a bar chart. And if you can't see, it's boxing, taekwondo, Greco wrestling, and freestyle wrestling. And you have red, blue.
What is Greco?
I'm not sure the difference. So you have this. All right.
Yeah, it's not like what they do in America.
50, 122, 272, 80, 35, 45, 25, 26, 51, 54, 26, and 28. And there's the table. You guys need to, what's the first thing you're going to do? We have the data. What did you say? We need to turn our data into percentages. So we need to figure out red's winning percentage and blue's winning percentage. How do we do that? Divide. Yes. Divide what?
You're running from the total.
Okay, we are going to divide the red by the total to get the red's winning percentage, and the blue by the total. Red by the total, blue by the total. Or you can do red divided by the total, then subtract that percentage from 100. All right? And then you're going to make a bar graph, just like we did for number 3 on the homework that we went over. All right, so I'm going to give you guys 10 minutes to work on that. I'm going to also pass out calculators so that you have calculators to divide stuff. All right? Watch your phones away. I'm giving you calculators. Alright, so I think just if you know how to get the percentages, then your graph typically looks pretty good. Alright? So again, we need to remember, alright, that in order to create a graph, we need to have the percentages. Okay, so in this case, we're talking about win percentage. And win percentage is always going to be, number of wins divided by total gains. Alright, so find the win, so you have to find the win percentage for boxing. Alright, so boxing and red, so boxing red, you do 150 divided by 272. Okay, that's going to give you 5%. Then you're going to do boxing blue. Okay, that's going to equal number of wins, which is 122 divided by total. Okay, 122 divided by 272. That's going to give you something, and I think you guys saw this. It's going to give you like 44. It's going to give you 0.44, like maybe 785. That one is on an 8. So 0.448. That 8 bumps that up. So instead of 44%, it's 45%. That 8 right there bumps it up. So that's equal to 45%. And the way you can tell if you should round up or not, if you have 55 and you put 44, and you do 55 plus 44, you're going to get 99. What should your percent be after you add it together? 100. So 45 and 55 add to 100. All right? Good. You want to add up to 45. All right? So, at this point, guys, I want to get to this next part. All right. So if you still need help on that, okay, you need to come see me outside of class. Okay. How many of you guys feel a little bit better after doing that example? That's always the goal. All right. It might have helped if I had gone over a few more examples like this in class. And that was initially my goal, we ran out of time. So one last question right here. Okay, here's a pie chart for you of this data. It says the following pie chart shows the number of red victories in each of the 4 sports. Explain why this chart does not help address the question about uniform colors. Maybe. He said it doesn't have a percentage. I could possibly figure out information about it still. What else? It doesn't tell you the total games. This is a chart of the red victories. All it tells me is about red. It doesn't tell me anything about blue. How do I know blue didn't win 300 games? How do I know blue didn't win 50 games here? How do I know blue didn't win more games here? I don't. It's all about red. Another reason why this graph could be messed up. Any other ideas? How many of you guys found the winning percentage for Taekwondo for red? What was the winning percentage for Taekwondo red? 56, right? Over half. Is this slice of the pie over half? No, this is like 20%. This doesn't even make it look like the red. It doesn't make it look like the people in Taekwondo that wear red win very much. It makes it look like a 20% piece of the pie. Instead, really, it's 56%. So this proportion for this piece is not correct. All right. So we have a few notes that you have to take. Now the stuff highlighted in yellow is what you need to write. All right. Okay. So actually, let me highlight just a few more. That way you don't act crazy. So you need to write that. You need to write down what's in yellow. Alright, these are important, you need to write these in your notes. So what we have, and this is an important equation, and here's a hint. Circle this, put stars around this. There's going to be a question on a test at some point in time that's going to ask you, what is the equation for performance? There it is. Performance equals ability plus random chance. Okay? So what do we mean by performance? Performance is an observed value that describes what the athlete actually did in a specific context. We can use an athlete's performance to estimate his or her ability. Again, the important stuff that you need to write is in yellow. Performance describes what the athlete actually did. Use performance to estimate his or her ability. So what do we mean by ability? Ability is a true but unknown value that describes what the player would do if given an infinite number of opportunities in the same context, i.e., for example, same physical conditions, location, opponents. Again, ability is a value that describes what the player would do if given an infinite number of opportunities. Alright? I'm being nice. Eventually you guys get good at taking notes. I won't have to highlight the sort of the key important stuff that you could do. That's what you learn how to do. I'm imagining that most of us are done writing this top part, so I'm going to scroll down. For random chance, I want you to write that whole line. Alright, random chance. You need to write what's in the yellow. I've said that like several times. For random chance, I want you to write the whole thing. It says, random chance describes the variation between an athlete's performance and his or her ability. Alright, that random chance is always there. Why? Because it's real life, and real life is not perfect. There's always some place where random chance is going to find a way to sneak in. I'm going to give you guys, let's say, another minute to get that written down. Put some time pressure on you guys so you get a little bit better at writing it fast. Again, this idea of performance, this idea of ability, this idea of random chance, this is going to be the focal point of the school year in this class. We are going to be focusing on performance, ability, and random chance throughout this year. Talking about what causes a drop in ability, what causes an increase in ability. How do we know when the ability of someone dropped or increased? Alright, it's not always, oh, they shot bad, so their performance decreased. Alright? $30 seconds sound good for a little bit for get the rest of those written down? Good. Okay, another 15 seconds. Also, since you guys will be done with the calculators, I'm not going to collect them now. Just go ahead and make sure you have that lid back on them. Alright, so we're going to get Let's go ahead and look at this next part. Alright, so, yeah, remember, if you didn't get it all the way down, this will be online. You can go and check it out. Alright, just go to the website, follow the link to the YouTube video. So we've talked about it. You do not need to write this down. Okay? We've talked about this. We've talked about if student 1 flips 7 heads and 10 coin flips, I'm going to put them on my team because that's what's up. They're good at flipping heads. And student 2 that flips 2 heads and 10 flips, he's garbage, not going to ever be on my team. He probably should just quit at ever flipping coins. And that person's not going to be on my team ever. Would that be fair of me to give student 1 the spot on the team and cut the other? The answer, no, because as we go on to see, it says, does the first student really have a greater ability? No. Michael has a 50% chance of hitting heads. All right. Dean has a 50% chance of hitting heads. All right. All of you in this class, I'll give you this point, have a 50% chance to flip the heads. All right. So no one has a better ability to flip heads. The next question that we look at is, if I let Dean flip this coin 1,000,000 times, all right, what would happen? How many heads would he get? If I let him flip it 1,000,000 times, about how many heads do we expect him to get? Dean says 500,000. Dean, what relationship does 500,000 have with 1,000,000? It's half of it. You just said that their ability is 1,000,000, or million. Their ability is 50%. All right. And what we've been saying is, the more and more that you flip a coin, or the more and more that you perform whatever you're performing, the closer it gets to your ability, which leads to this. Not this. Apparently, based on my slides, it's going to lead to something though. All right. So wait just a second. So I want to look at this now. Anyone know who Sue Bird is? No. Another woman, basketball player. All right. Happened to be in the book. So it says, suppose Sue Bird's ability to make a free throw is 50%. During a game, she is fouled while attempting to shoot and is awarded 2 free throws. When she steps to the line, she misses both of them. Does this mean that her ability to make a free throw is 0%? No. No. What's her ability? 50%. How come it didn't just change even though she just missed both? She missed both, right? She could have made it or missed it. She still has a 50% chance of making that next one. Alright? So the way to look at it is this. Flipping a coin and shooting a basket the same way. I got a 50-50 chance to make it, right? At least in this scenario. So if I flip this coin, I got a heads. Does that mean that my ability to get heads is 100%? No. Still 50%. Does it say the first time I flip a head, when I get a tail, does that mean my ability to get heads is 0%? No, I still got 50%. It doesn't. I still got a 50% chance. All right. So the ability doesn't necessarily change just because the performance is not the same as the ability. All right. So performance is not the same as ability. That's kind of important. All right. Performance is not the same as ability. You might want to write that down. All right. Performance is not the same as ability. Okay. Is ability the same as performance? No. Trick question. Sometimes it can be. If I shoot 50% and I make 1 out of 2, now my performance is the same as my ability. We're going to talk about that. So, performance is not the same as ability. So you don't have to write this. Alright? When analyzing sports, how many of you guys have watched Sports Center? Okay. usually the people that are analyzing sports are interested in the athlete's ability rather than their performance. Okay? How many of you guys know what fantasy football is? Okay? I just did a draft last night. Okay. So I don't care what they did how they performed in preseason football. What am I looking at? I'm looking at their ability based on last season. Okay? So to predict how well an athlete will perform, we will want to know his ability or her ability from the previous season. If I'm going to draft Antonio Brown, I need to know what his ability looked like last year. Last year he had a really good season. So I'm using that to predict that he's going to have a really good season this year. Okay? Question to you guys. Can we ever know an athlete's ability? Can we ever truly know an athlete's ability? No. No. All right? Because, for what we do, we use an athlete's performances to estimate their ability. Okay? It will never be exact. And the reason being is because Michael Jordan can't shoot an infinite number of free throws. We will never know what his exact ability would be because he would have to shoot forever and never stop shooting ever. Even when he's dead, he'd still be shooting baskets. And he still wouldn't have to be able to know because it has to be an infinite number. All right, so we cannot ever really know an athlete's ability. We can use an athlete's performance to estimate their ability. So what I would suggest writing down for this screen is we can use an athlete's performance to estimate their ability. All right? We can use an athlete's performance to estimate their ability.
Who's your first pick?
Tens. I had the number one overall pick in one draft that took Le'Veon Bell. I don't care about suspensions. And took Antonio Brown as my number 4 pick. Picked Antonio Brown for that. My running backs a week, but my wide receivers in that league rank average 18 points a one everyone.
What did you learn? Never play fantasy football with an guy. Look for that. Hey, you're trying to win that house now.
Everyone got this? We can use an athlete's performance to estimate their ability. Tim Tebow, yes. We can use Tim Tebow as an example. In college, really good. All right, his performances are really good in college. We estimate his ability to be good in the NFL. Exactly. Devon, exactly. Can we ever really know an athlete's ability? No, we didn't have enough information about Tim Tebow. All right, so real quick, I want to do this here, so I want you guys to know how to simulate. We're talking about how to simulate someone's performance. Heads is a make, tails is a miss. All right, so I flip a coin. All right, I get a tails. We're simulating two birds' performance right now. So a tails is a miss, so she missed. If she misses, what's her overall shooting percentage after that first shot? 0. Good. All right. So again, tails again. Miss. What's the shooting percentage still? 0. Because she is 0 for 2. So again, tails again. So that's a miss. What's her percentage? 0. 0 because 0 3. So again, tails. Miss. Still 0. Heads. So Bonnie made it. So her percentage is 1 of 5, which is, anyone know? Good. 20%. All right. So again, heads. All right, she made it. So we now have 2 of 6, which is good. 33%. So again, tails. It's a miss. So now we have 2 of 7. Anyone know what that is? You got it on? So 28. Alright. Tails. Not good for her right now. She's struggling. So it's going to be 2 out of 8, which is 1/4. Alright. These next ones, heads. Made. Now we have 3 out of 9, which is 33. Nope, this. So 3 out of 10 would be 30%. Okay, so 30% is her performance. Does that mean that her ability is now 30%? No, it's still 50%. All right, and so what are some things that could affect her during? What are some random chances that could affect her? What could affect her ability, her performance? She'd be sick, nervous, tired. It's the end of the game, right? She's getting ready. She's losing. She needs to make these next free throws. Pressure. All right. Maybe she's not clutch. We're going to talk about that term later. All right. So let's look at this now. So here's another simulation that they did on the computer. It says, now what happens if you look at her first 100 attempts, her first 500 attempts? This graph right here, they did a simulation just like I did, only they used a computer. And this is her graph of her first 100 attempts. After 1 attempt, she's at 0. 2 attempts, 0. Then she jumps up to about like 35 or something, and jumps up, and now it's like moving around, you know. What percentage do we say she shoots? 50. So what I want you guys to see is this. If we look at this, we put right here at 50. What should happen once she starts shooting a bunch of free throws? Her performance should be close to what? 50. So I'm going to do is I'm going to draw a straight line out from performance. From 50. All right, make sure it's straight. So there's the line for 50%. Notice what happens out here. She's above 50% a little bit. Now she's under. You know, fluctuating a little bit, maybe a little bit over right here. But then you get further and further out. 50%. Well, is it horrible for her? That's good for her. She's shooting her average. She's shooting her ability at that point in time. All right? So, what that leads us to is this, and this is the last thing that you need to write down for today. That leads us to the idea of the law of large numbers. All right, so the law of large numbers says an athlete's performance, and we've said this before, we're just actually stating it formally now. An athlete's performance will generally get closer and closer to his or her ability as the number of attempts grows larger. An athlete's performance will generally get closer and closer to his or her ability as the number of attempts grow larger. Okay. An athlete's performance will generally get closer and closer to his or her ability as the number of attempts grow larger. That is called the law of large numbers. So, just to show you guys another, real world example here. Again, I don't keep using LeBron James because I like LeBron James. I keep using LeBron James because that's what the book bases this chapter on. All right, so this is true of any player. I didn't say that. I don't like it. So if we look at this, game 1, in 2008, he made 0 of 2 3-pointers. He was shooting 0%. Game 2, he made 3 of 5. So now he's shooting 42.8%. So as you see, it keeps fluctuating, all right? And after 82 games, 31.5%. And as you can see, if you look at this throughout, all right, 31.5 would be like right out there. We draw a straight line out. Up. Lo and behold, his percentage or his performance winds up being right around his ability. Okay.